Hi everybody, in this lesson, I am going to help you solve some problems on basics of fractions. So let's get started right away. The first problem says the shaded part shows 3 over 4, true or false. So let's take a look at this picture carefully. The whole circle has been divided into 1, 2, 3, 4 parts. 3 of those 4 parts are shaded. So does this represent the fraction 3 over 4? Well, not really, because the 4 parts in this case are not equal. You can clearly see, for example, the second part here is more in area than this first part here. So these 4 parts are not equal, and therefore the shaded region does not represent the fraction 3 over 4. So this is false. Here's the next one. Which shape shows 3 over 4 correctly? So let's take a look at each picture one by one. This first one here has the rectangle divided into 1, 2, 3, 4 parts, and 3 of those 4 parts are shaded. So does this represent 3 over 4? Well, once again, not really, because the 4 parts are not equal. So this is not 3 over 4. What about this one? So let's see. So the rectangle has been divided into 1, 2, 3, 4 parts. Are those 4 parts equal? Well, you might look at this picture and your first reaction might be the parts don't look equal, but actually these parts are equal. Why is that? Well, because this line here, this vertical line, divides the whole rectangle into 2 equal parts, and then this line here divides the left half into 2 equal parts. So this one and this one are equal, and this diagonal here, this oblique line, divides this right half into 2 equal parts. So therefore all 4 parts are equal, and 3 of those 4 parts are shaded. So therefore this shaded area here does indeed represent the fraction 3 over 4. What about this one? So we have the whole rectangle divided into 1, 2, 3, 4, 5, 6, 7 equal parts. The parts are equal here, as is visually obvious. 3 of those 7 parts are shaded. So this is actually not the fraction 3 over 4, but 3 over 7, because the total number of parts is 7. So therefore this is not 3 over 4. What about this one here? So here the rectangle has been divided into 1, 2, 3, 4 equal parts, but only one of those 4 parts is shaded. 3 are unshaded, and therefore the shaded area here actually represents the fraction 1 over 4 and not 3 over 4. So which shape shows 3 over 4 correctly? This second shape over here. So that's the answer in this case. All right. What fraction of the shape is shaded here in this picture? So let's try and figure that out. So we have this triangle here, we have this triangle here. So how do we find out what fraction the shaded area represents? For that, we have to figure out how the shape has been divided and how these parts have been created. So what we can do is, I can draw a horizontal line like this, and then a vertical line like this, and then I can also draw this oblique line, slanting line here, and this slanting line here like this. And now it is instantly obvious that the whole rectangle is being divided into 1, 2, 3, 4, 5, 6, 7, 8, 8 equal parts. 2 of those 8 parts are shaded, and therefore this represents the fraction 2 over 8. The reason this problem is difficult initially is because this division into equal parts is not given, it's not drawn in the picture, and that is what you have to figure out, and that is what makes this problem challenging. But once you do that, it's immediately obvious that this is the fraction 2 over 8. Now here's the last question of this lesson. What fraction of the shape is shaded? So we have this hole here, which is a hexagon, and some part of that hexagon, which is this triangle inside, is shaded, and we have to figure out what fraction of the shape is shaded. So this is actually quite a challenging problem. So if you want, you can actually pause the video here and try and figure it out on your own before you see how I do it. So once again, what we have to do is somehow figure out how to divide this hexagon into equal parts and then count the number of shaded parts which make up this inner triangle. So how do we do that? In this case, what we will need to do is join the opposite vertices of the hexagon. So let me draw this horizontal line like this, and then this diagonal here like this, and then this diagonal here like this. So do I have equal parts? Not yet. But here's what I can do further. I can draw a horizontal line like this here, and now I begin to see equal parts emerging. So you can see this part here, this part here, this part here, they all look equal. Let me also look at the parts below here in the lower half. We can clearly see that some of those parts are larger. So what do? I can actually now draw a line like this. So from the middle here to the middle here, and then I can draw a line like this. Wow. Okay. Now, if you look at this picture now, you can see that the total hexagon, the whole hexagon has been divided into equal parts. And let's now count those equal parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 parts above the middle horizontal, and therefore there should be 12 parts below the middle horizontal. So there are a total of 24 equal parts that we have divided the hexagon into. And how many of those parts are shaded? So we have 1, 2, 3, 4, and then 5, 6, 7, 8, 9. So 9 parts are shaded out of a total of 24 equal parts. And therefore, the shaded part, the shape that's shaded, it is the fraction 9/24 of the overall hexagon. So that solves the problem, and that completes this lesson. Thank you for watching.